Imagine you're reading a story and you come across the sentence, "I deposited cash in the bank." Now compare that to, "The children played near the muddy riverbank." Same exact spelling, but a completely different meaning. As humans, we don't even pause to figure this out. Our brains automatically use the surrounding words to know which version of bank we're dealing with. But for early artificial intelligence, this was a massive roadblock. Machines couldn't tell these meanings apart, causing them to fail at basic reading comprehension. To understand why, we have to look at how older language models, like Word2Vec, worked. They translated text into lists of numbers called vectors, which act like mathematical coordinates for meaning. The problem was that they used what is known as a static embedding. Think of this like a permanent ID card assigned to every word, and that ID card never changed. Because the machine only had one ID card for bank, it blended conflicting meanings, like financial loans and muddy water, into a single confused representation. These systems treated language like a rigid dictionary, ignoring how the words around a sentence actually dictate what a word is supposed to be. This changed with a breakthrough called ELMo, which stands for Embeddings from Language Models. ELMo solved the fixed meaning problem. Instead of relying on a static ID card, ELMo creates a contextual embedding. This means it generates a brand new, customized set of numbers for a word based entirely on the specific sentence it lives in. Think of a word like an actor. The same actor plays different roles depending entirely on the other character words sharing the stage with him. When ELMo sees the word bank surrounded by words like loan and credit, it puts on a finance identity, but surrounded by river and muddy, it assumes a geography identity. Resume normal pace. This shifted the focus of AI. It stopped looking at words in isolation and started analyzing the ecosystem of the entire sentence. To figure out that ecosystem, ELMo uses what's called a bidirectional language model. Bidirectional simply means it reads in two directions at once. First, ELMo reads forward, from left to right, to see the words that come before the target word. Simultaneously, it reads backward, from right to left, to see the words that follow. By scanning from both sides, ELMo ensures that a word like not properly flips the mathematical representation of good from a positive sentiment to a negative one. ELMo also goes deeper than the sentence. It looks inside the spelling of the word itself, using what's called character-level representation. Notice how the word playing breaks apart here. By analyzing the letters, the AI recognizes shared roots, connecting playing with played or player. This prevents the AI from failing when it encounters rare vocabulary or new word forms it hasn't seen before. These context-aware vectors immediately upgraded the systems computers use to understand our language. It improved the AI's ability to label parts of speech, enabling it to distinguish the physical book you read from the action to book a flight. It also improved how machines identify specific names like people or companies, a task called named entity recognition. Now the machine knows Apple, the fruit, is different from Apple, the tech company. By removing this confusion, ELMo allowed AI to make accurate decisions based on what a person actually means, rather than just the words they used. While revolutionary, ELMo used an older memory system that processed text one word at a time. This was slow and sometimes struggled to connect ideas across very long paragraphs. That paved the way for newer systems like BERT, which use attention to look at every word in a sentence simultaneously. ELMo was the crucial bridge that moved the industry from simple dictionary lookups to understanding sentences as a whole. It was the first major milestone to prove that a machine must read the whole sentence before deciding what a single word means.